So what are some of the pros and cons? First of all, deep learning, deep neural networks especially, are very powerful models, and some very complicated problems such as computer vision and audio are solved through deep learning. However, they also have some drawbacks. First of all, they are prone to overfitting. We'll talk more about this later, but overfitting is when we train a model and then when we deploy it in the real world, performance is worse because the model has confused the signal with the noise. They have many hyperparameters. Like in SVMs, we have to choose a kernel, and each kernel has different parameters, and this can be a complicated process. Deep neural networks have many different choices we have to make around the activation functions and the structure of the network. So in practice, it takes a long time to find out which is the best structure for a given problem. And finally, deep neural networks require lots of data, and this means they also require big machines in order to train them. So they're not very efficient. That being said, they're some of the best models we have in machine learning, and they have been used successfully in many complicated problems, mainly anything related to language or computer vision and audio. So let's move on and talk about lazy learners, or else instance-based learners. So let's say that you have an exam and you have to study for it. So you can either, let's say, study 3 months before the exam takes place and solve exercises every day and try to get better at what you're going to be examined in. Or you can just delay everything until the very last minute and try to cram everything in the last hour, let's say. So lazy learners are a bit like the second example. So these are learners that essentially they do no learning and they delay any training or decision until they see a new instance. So the good thing about lazy learners is that they have zero training time, so you can just add more data as they go along. However, when deployed in real time, they can take a long time to run because essentially every new data point makes them slower. So the only actual working example in practice of a lazy learner is the algorithm called k-nearest neighbors. So let's see again our famous example of spam and ham, where we have two variables, the new recipients and the email length. So we have a new data point. How would you classify this? Think about it for a second. It's not too easy to find a solution. You can see that the neighbors of this data point, they all seem to belong to the orange class. So it would be a reasonable assumption to say that, hey, maybe this data point should also belong into the orange class as well. So this is the idea behind k-nearest neighbors, that you just define the parameter k, which is the neighbors, and then you just look for a new data point what those neighbors look like. And then these neighbors vote. So if all the neighbors are orange, then yes, this point is orange. And here's another example. This point has two red neighbors and an orange neighbor. So in this case, the red is going to win. So obviously there are some questions here, such as what should be k set to? This is a hyperparameter for which you need to find the optimal value. And also, what distance measure should be used? We're talking about neighbors, so we're talking about distance. And even though distance in the real world is quite well defined, that's not always the case in machine learning, especially when we're talking about spaces that can have 10 or 20 variables. Quite often, we use the Euclidean distance, which is distance as we understand it in the real world. However, there are some other choices of distance measures which might make more sense for some problems.